So we have two subpart for this question. A power transmission shaft, which is made of C45 steel, which is supported by bearings. So that the distance between bearing is 2 meter. Shaft, which carries a 200 diameter of pulley. Okay, which is having a weight of 1 kilonewton, and it is placed at exactly at the midpoint. That pulley receives power by a belt drive. Okay, this shaft, which transmits power by another machine by means of a flexible coupling this outside the right bearing. So that's the way of its the shaft get the power transmitted is 20 kilowatt and at 120 rpm. Okay, the ratio of the belt tension is 3:1. Okay, the pulley is having a belt, so there will be slack end and tight end, so there will be tension. That the ratio of tension is 3:1. You have to determine the size of the shaft. Size of the shaft means you have to find the diameter of the shaft. And also you need to find the twist. Okay, that's all about the first part. Second part is we have to compare the strength or stiffness of a hollow shaft of same external diameter. In the first question we are having an solid shaft for the same outer. I mean, solid shaft will having only one diameter, but the hollow shaft will having a inner diameter and outer diameter. The outer diameter of both solid and hollow will be same, right? Only there's an inner hollow part will be in the case of hollow shaft, so there will be in additional inner diameter for hollow shaft. So we have to compare the strength and stiffness of a hollow shaft of the same external diameter as that of a solid shaft. Diameter ratio of hollow shaft is 0.60. Okay, so let's look at the solution part. So we have written the given condition. We have W as 1000 Newton and the power as 20 kilowatt, and total length between the bearing. Always the L means the length between the bearing. So bearing to bearing distance is given as 2 meter. That will be 2000 mm. Then RPM, that is 120. And since we have only one pulley, I'm assuming the tension in the pulley to be as T1 and T2. So obviously the ratio of tension will be T1 by T2. Okay. Whenever we are taking in this manner, we always assume the T1 to be the larger value and T2 to be the smaller value. So T1 by T2 would be 3. Then G is also given as 0.8 into 10 raised to 5 Newton per square. Okay. So we have to determine the first part is we have to determine the size of the shaft. That means we have to find the diameter as well as the twist. Okay, theta, we have to find the twist. So in this question they haven't given the pulley diameter, which is essential for solving the problem. So let's assume to be as 200 mm. Okay, so this is a simple diagram based on the question, and this is a side view. Okay, we have the pulley having a tension, one tight side and one slack side, and the weight which is acting vertically downward at 1000 Newton, because it's all about the given condition figure. Now let's look at the vertical load diagram and horizontal load diagram and the equation or need to solve this problem. So this is a vertical load diagram. So this point A and point B are a bearing point. So it will having a reaction for vertical component as well as horizontal component. Since we are considering the vertical load diagram, you will only need to consider the vertical forces. So RAB and RBV are the reaction force. I mean vertical reaction force component. So I have written as RAB and RBV. Then at the exact center at point C, we having a pulley weight W which is acting vertically downward. So these are all the forces that considering in the vertical load diagram. Okay, I mean the forces in the vertical direction. Then this is the horizontal direction. Obviously, we'll be having a horizontal component for reaction at the point A as well as point B. Speaking of point C, we know there is a tension given and due to the horizontal direction. So it can be either upward or downward. Doesn't matter. You can put either direction. If you get the answer as minus value, that means the actual direction was meant to be in the opposite direction. Just taking it as in downward direction is more convenience. You can take it as upward also. You get the answer as negative. Okay, you only have to consider the magnitude. That's the only difference. So RAH, we have RBH and T1 plus T2 in the downward direction. Okay. Uh, Another fact, if you look in the question, they haven't given any shear stress value or maximum shear stress value or maximum normal stress value. Usually in this type of question, they should give the value in order to determine whether we have to solve it by maximum shear stress theory or maximum normal stress theory. Just say I am solving this problem by maximum shear stress theory by assuming to be a given value of maximum permissible shear stress as 54 Newton per mm square. Suppose in this question, this question can be varied in different ways. Suppose they are given maximum shear stress as well as normal stress value, then we have to find the diameter by both maximum shear stress theory as well as maximum normal stress theory. Okay, so I am assuming this question only have a value of maximum shear stress, then obviously you should only solve it by maximum shear stress theory. That's the way in which I am solving, just assuming having a value of maximum permissible shear stress as 54 Newton per mm square. Okay, that means now this question only have the value of shear stress, so obviously you should solve it by maximum shear stress theory. This is the equation for maximum shear stress theory. This is the required equation. We have to find the m and the t. That's the only task we have to do. Remaining cm and ct are the factors related to fatigue and torsion. That's I have to assume at a certain value. I will tell that later. Our only task is to find the value m and t. Okay, let's look. So next we have to find the torque. So this equation for torque, which is 9.500 10 raised to 6 into p by n. This is the value of torque 1.59 into 10 raised to 6 Newton mm. You can find it in my data book. Now we have the torque on the pulley, right? Or it's torque on the shaft. This torque will be equivalent to the, this formed due to the difference of tension on the tight and slack side of the pulley. So I can equate it T as T1 minus T2. Since we have only one pulley, we only need to take this one equation. So that torque will be due to the difference in tension value of tight and slack into the radius of pulley. You get the equation as T1 minus T2 is equal to 15,100 Newton. Okay. We also have the ratio of T1 by T2 as 3. So by that you will get the value of both T1 and T2. Okay. Now let's now we have find the first part. Now we have find the T. Okay. Then next we have to find the M moment. Okay. So to not to find the maximum bending momentum, first we'll be considering the vertical load diagram. So point A and B, it's a hinged point. So obviously MA will be 0 as well as MB is equal to 0. So I'm taking MA to be 0, that equation. So RBV into 2000, that will be in the anti-clockwise direction about the point A. What W into 1000 will be in the clockwise direction. So obviously this should be in the opposite sides of the equation. So based on this, we will get the value of RBV. Okay. So since it is in equilibrium, we have taken the moment equilibrium. We can also take the force equilibrium. That means all the force in the upward direction is equal to all the force in the downward direction. We know RAV and RBV, that's reaction force, is in the upward direction. The weight will be acting downward. So by that you can equate and find RAV. Okay. Now we have RAV and RBV. Why we find RAV and RBV is to actually find the moment along the vertical load diagram. That's our ultimate aim. So if we take looking at the vertical load diagram, MAV will be 0 because there is no force causing a moment along AB. Okay, that vertical component. Similarly, MBV also 0, but there is a moment will be caused at the point C. Okay, because that pulley is placed at the exact middle, that moment can be due to RAV force or RBV force, right? Because that the pulley is placed at the exact middle center, so it can ex- uh, exert any moment. Okay, it can be implied any moment can due to both force RAV and RBV. Since they are symmetrical, you can take uh, any one of this, either RAV or RBV. I am taking RAV, and the distances will be 1000, right? So that will be 500 into 10 raised to 3. Okay, So now we got the component moment component along the vertical component at point C. So only point having moment is C, and we have the vertical component. Same way we have to take the horizontal load diagram and find the horizontal moment component at point C, because there is no other point having momentum. Only point having moment is point C, which is having both vertical component and horizontal component. That's our aim to find. Okay, now let's look at the horizontal load diagram. So speaking of the horizontal load diagram, same way we can take the moment. Okay, so I'm taking the moment same way at point A. So RBH into 2000 will be equal to T1 plus T2 into 1000. We can simply look, it's simply the moment equilibrium condition. I mean, anti-clockwise will be on the one side and clockwise will be on the other side. So here I have taken A as the point of moment, equating to be 0. Okay, that's how we get the RBH value. Similar way, you can take the force equilibrium. That means upward force will be equal to the downward force, right? So RBH will be equal to T1 plus T2. Now we got both the value of RBH and RAH. So talking of the horizontal load diagram, similar way there will be MAH and MPH will be 0. Okay, there is no moment along the horizontal component at point A and B. But MCH will be having a moment. Could be due to RAH and RBH, right? Because that is placed, already told that is placed at the exact middle. Okay, so I'm taking RH as you can either take RH or RBH. Here I'm taking RH, so you get the value of MCH. Now we got the value of MCH and MCV. That means the moment, horizontal component of moment and vertical component moment at point C. But you have to find the net moment at point C. That is what we need to substitute in the equation. So how do you find that? So in order to find the resultant moment at point C, square root of basic resultant moment equation, MCV square plus MCH square. So you get the resultant moment at point C, MC as 15.91 into 10 raised to 6 Newton mm. Okay. So substituting to the equation I have shown earlier, we get the value of D as the 131.2 mm. Okay, we have to assume the value of CM and CT to be 1.5 or CM to be 1.5 or CT to 1. You can assume any value. Okay, the value won't be sometimes given the question, but you have to assume it. So based on substitution, we'll get this 131.2 mm, but you cannot take that value. From the database, you can find the standard shaft diameter. There is a page which shows the standard shaft diameter. So based on that, next standard value will be 140 mm. So this is the diameter of the shaft. So you are also asked to find the angle of twist. Can be found out by the equation shown. This also can be found from the data book. So we have all the value. We have to know the value of T. We know the value of L. We know G. We know D. What I have to do is just substitute and find the value in degree. Okay, so the angle of twist will be 0.03, not 2 degree. We have also asked to find the, compare the strength and stiffness with an hollow uh, shaft of the same outer diameter. So talking of the strength, that means torsional strength, we have to consider polar moment of inertia. Okay, whenever we are asked to compare strength, that means we have to compare the polar moment of inertia of both the shaft. In this case, we have solid shaft and a hollow shaft. So all I have to do is just take the ratio and just express one with the other. Okay, that's the only thing we have to do. So the equation for polar moment of inertia for solid shaft will be pi d raised to 4 by 32. For hollow, that will be pi d raised to 4 minus, outer minus inner. Okay, so the outer diameter of the hollow shaft will be same as the outer diameter of the solid shaft. So we can take the capital DS, DC, DO. They both are same, right? So the like terms will be cut, and we also have the condition that di by d will be zero point 0.6. The inner to outer of the hollow, that ratio is also given as 0.6. So taking the ratio between solid and hollow, you can substitute that equation, that relation, and finally we got the hollow shaft is 87% of solid shaft. Okay, that's the final relation will be getting. Okay, that the remaining 13 will be hollow, only 87% of the solid shaft. Similar way, we are also asked to find about the stiffness. Okay, stiffness also depends on the polar moment of inertia value. So same way we have to take the ratio between the hollow or solid, or solid between, or solid and hollow, and express one after other. So since we have taking the stiffness widely also depend on the polar moment of inertia, we are also giving the same result. I mean 87%. Okay, the hollow will be 87% of stiffness of solid. So this is a way to solve this question.